Hello students, welcome to lecture of Kinematics and Theory of Machine, and myself Patel, and we are going to solve another example from chapter Velocity and Mechanism, and we are going to solve this example based on relative velocity method. Okay, let's start. Okay, so as you can see on the screen, the given data, the crank and connecting rod of theoretical steam engine are 0.5 meter and 2 meter long respectively. So length of crank is a 0.5 meter and length of connecting rod is a 2 meter. And crank is rotating at a 180 rpm in a clockwise direction. When it turns 45 degree from inner dead center position, we have to find the velocity of piston. Second thing we have to find is the angular velocity of connecting rod. They say find the velocity of E point on connecting rod, which is a 1.5 meter away from the gajinti. And fourth point we have to find here is the position and velocity of any G point on a connecting rod which have a least velocity related to crankshaft. So right now we have to find the position and velocity of that G point. Okay, so as you can see on the screen, what is the given? The crank OB is a 0.5 meter and connecting rod PB is a 2 meter. So how we draw this space diagram or configuration diagram? What scale we have to take? So first of all, you can see the largest dimension is a 2 meter and smallest dimension is a 0.5 meter. So crank will be very small. So we have to choose the scale here very carefully. Otherwise, what will happen? Our crank will be very small. So let's take this scale here. 10 mm is equal to 0.25 meter. So you can see 0.25 meter is equal to 10 mm. So 1 centimeter. So our crank will be 2 centimeter approx. And PB, which is our connecting rod, is a 2 meter. So what will be the length of connecting rod with respect to this scale? So you know that the connecting rod is a 2 meter. So our length in a drawing, length of connecting rod in our drawing will be 8 centimeter. Okay, if you take the larger scale, what will happen? Our crank will be large, but you can see with respect to crank, connecting rod will be very large, which is not suitable to draw. So here let's start draw this diagram here, and how you will draw this. So first of all, you will take here this O point, which is the center of crank. Then how you know this angle is here 45? Because they have said that when turned to 45 from inner dead center, means inner dead means extreme position will be here, like this is the piston connecting rod, and this crank, this is the crank. When this piston moves inside from inner dead center, this crank will moving in this direction, and when this crank is rotating and making some angle which is a 45, okay, then position will be like this, and we have to draw this position in this example. So first of all, we put here the center of the crank, which is O, then length of that crank. Now how you will put here the connecting rod? Angle is not given, so you have to first draw the line of action of this piston, which is like, you can draw like this is the line of action of piston, and then you will make some arc. You will make the arc according to this 2 meter, which will be 8 centimeter in our drawing. So you will take here compass and making some arc here, and whenever this arc intersecting at some point here like this, and this intersecting point will be the position of this piston or slider, and you will connect that to our end of that crank, and you will get here this B point, and this piston is a P, and you can draw here like this cylinder. So you will get this space diagram. Okay, so now you have to draw the velocity diagram. How you will draw the velocity diagram? So first, you know that for any velocity diagram you need the velocity of any one of that element, and in most 99% they will give the velocity of crank always, because in this case they have given the RPM of crank OB. So from using that, you will find the angular velocity 2 pi n upon 60. You will put here 180 as the RPM, and you will get the angular velocity of this crank. And this crank is rotating in this direction. Okay, as you know that from inner dead center, piston moving in this direction, so crank is moving in a clockwise direction. So angular velocity is at 2 pi n by 60. You will get 18.85. Then linear velocity is equal to angular velocity into OB, length of that link. And we know that crank length is a 0.5 meter. So we get here the linear velocity of V, means velocity. Right now, let's understand that. You can see here the velocity of BO means velocity of B with respect to this O point, and which will be the in direction of this perpendicular to link in this direction. But sometimes it also, we can write here velocity of B only, because this velocity of B is with respect to O point, and O point is a steady or a zero velocity point, because this O point is not moving, okay, with respect to any other element. So whenever we take the reference with respect to any fixed point, like whatever fixed point, so we can avoid that alphabet here, and we can directly write here with respect to only VB. So velocity of any point with respect to fixed element, we can write here directly. But whenever we writing the velocity of any element with respect to other moving element, then we must write here like this. This is the moving element. Okay. So we find here the velocity of B with respect to O is a 9.4 meter per second. So we have to select some scale here first. We have to select the scale for the velocity diagram. You can see the 9.4. So we can draw 9.4 in a centimeter also. So we can take directly the scale. 10 mm is equal to 1 meter per second, or I can write here also 1 centimeter is equal to 1 meter per second. So ultimately our first vector OB is equal to directly 9.4 centimeter or 94.2 mm. So I will draw this first vector. Okay, how you will draw this vector? Let's start the drawing of this velocity diagram. So first of all, you will know that the first rule, all the fixed point will be on a origin point. So first point will be like here. This will be small o, is with respect to this. With O, velocity of B with respect to O. So direction will be like here. Okay. Not in this direction, because we know the direction of the crank is in this direction, so our velocity will be also in this direction. So I will draw the first vector, okay, perpendicular to this link here, and from O to in this direction, and length will be, you know the length will be 94.26 mm. And this point you will get here will be the B point. So we have drawn the velocity vector of B with respect to O. Now, with respect to B, velocity of P. P is nothing but, right now we have to consider that as a slider. And you know that slider always sliding in this direction. So line of action of slider must pass through the origin, which is pass through the origin. Now, with respect to B, this PB is a link, and P point is on also this link also. So perpendicular to this link, like this direction of P with respect to B can be in this above direction also, like here, and it can be also in this direction. So I have to draw this perpendicular here, perpendicular to this link, is velocity of P with respect to B. So I will draw here this perpendicular like this, parallel to that. You will use the set square here and take this perpendicular from the B at intersecting point. This intersecting point will give me the P point, small p, and you will dark, now you will dark these lines here, okay, and erase the extra lines. So you can see here, this is the velocity diagram. you can see this line like OB. If I put here arrow in this direction, this is the velocity of B with respect to O. If I put the arrow here like in this direction, this is the velocity of P with respect to O. Or I can write only velocity of P because we are considering with respect to any fixed point. Okay. So if I write here like this, velocity of P with respect to B, this is the velocity vector. Okay. So this is the velocity diagram we get here. Okay. Now what they have said, what we have to find here, velocity of piston. As you know that in our space diagram, this P point, this P is a piston. In velocity diagram you see that this is the P point. So ultimately we need to find this distance. We will measure this distance and convert that into velocity using this scale. Okay. So let's start how you will find the velocity. So velocity of piston, for that we need to measure this O to P distance. In space velocity diagram, measure that distance and we have to convert that. So if you measure this distance, you will get 81.5 mm and we have the scale 10 mm is equal to 1 meter per second. So what will be for the 81.5? So you will get here by like 81.5 divided by 10 and you will get 8.15 meter per second. Okay. Now second point, we have to find here angular velocity of connecting rod. So as you know that angular velocity of connecting rod. So you know that connecting rod is nothing but PB. Connecting rod is a PB. So you can see here the PB vector. We will measure this vector by scale, using scale, and whatever data we get, we have to convert that into velocity. So if you measure this, you will get 68 mm and you know that from scale 10 mm is equal to 1 meter per second. So what will be for the 68? So we will get here 6.8 meter per second. So this is the velocity of connecting rod and this is the velocity of piston. Now third point, which is very important because so we have to find the velocity of that E point. So let's understand first of all, we have this space diagram and this velocity diagram, and what they have said, velocity of E on connecting rod PB 1.5 meter from Gaussian pin means this is the pin which is used to connect this connecting rod and piston. So Gaussian pin will be here. Okay, and from this 1.5 means around something here. So I will measure this 1.5 meter and put here some point like E. So now we will use the rule number 4. Okay, this is our first time, so I will explain you very slowly how you will find the velocity of any point on a link. Okay, so first of all remember that we have to locate that here on a space diagram 1.5 meter, as you know that. Now we will take the ratio with respect to space diagram and velocity diagram. Okay, let's check this. So I will take here reference point is a P. So I can write here P to E distance divided by P to B distance. On a space diagram, P to E divided by P to B is equal to, this ratio will be same on a velocity diagram. So P to E upon P to B. So this is for the space diagram here. This is for the capital is a space diagram and small is a velocity diagram. So P to E distance, you know that P to E, which is a 1.5 divided P to B. P to B distance will be here and you know that distance. So what we will do, this will be 2. Now P to E distance, we don't know the P to E distance. So P to E distance will be here divided by P to B. P to B, this distance, we have to measure this distance in a velocity diagram which is around 68 mm because we have measured that. So 68 mm, and you will, from this you will find some PE here, PE. So if you put this all value here, you will find this is the 51 mm. So how you will locate this P to E? So P point to E distance 51. So you will put some measure this 51 here and you will put this value E. So now as you can see, you can locate this point in a velocity diagram using this space diagram. Okay, and we need the velocity of this E point. How you can find the velocity of E point with respect to crank? So we have to connect this E point to our origin point, and then when you will measure this distance, which distance? This P to O to E distance, and you measure this distance and you will get the velocity of E, because as you know that this vector is indicating velocity of E with respect to O. Okay, using this formula, which is the rule number 4. So if you measure this, you will get the 85 around 85 mm. If you measure this distance, you will get 85 mm, but as per our scale, you have to divide that and you will get 8.5 meter per second. Okay, so this is the E point which we have to find here, and then we have to find the velocity of that E point also. Now next is, you can see the position, first of all position and linear velocity of G point on a connecting rod, which have least velocity relative to crankshaft. So how you will find the least velocity? P to B distance is nothing but for the connecting rod. So we have found already this E point. As you know that E point is when you draw this vector here, it is indicating the velocity of this E point. Okay, so now we have to find this some point on this connecting rod which have the least velocity, and this least velocity means, as you know that this distance is indicating the velocity on a connecting rod. As this point here, you can see the velocity is decreasing. So which point will be nearest to this O point? So we have to take the perpendicular. You will from this O, and means this intersecting point will be your G, which have the least distance, and this distance is nothing but minimum velocity on a connecting rod. Okay, let's check this. So now in this case, you will first find the position of this G point on a velocity diagram. Second thing, position means we have to find this G point on a actual connecting rod also. We will find this G point on a connecting rod. How you will find this position of G on a connecting rod? We have found the least velocity. So you will, whenever we are discussing any point on a link, then we will use the rule number 4 for the velocity of any point on a link. Okay, so let's see. So as you know that how you will solve this. First of all, in this case we know the G point on our velocity diagram. So I will take a reference point is a P. So P to G distance, this is the velocity diagram. For the velocity diagram, P to G distance divided by P to this B distance, P, B. We know the both value, okay, because we have located the G point on a velocity diagram, is equal to P to G, this is for the space diagram, this P to G, we don't know the position right now, upon P to B. P to B means this distance, we are talking about total distance, which is a 2 meter. So you will put this all value and you will find this P to G, and you will locate that point on a connecting rod. So you will get the answer here like 8 meter per second means OG. Means if you measure this distance here O to this G, you will get the around 80 mm, and you will convert that into 8 meter, and BG 1.47. So from B this G distance you will get 1.47, or if you have selected PG, so you will get from here also. Okay, So this is the example is totally based on rule number 4. Rule number 4, in that you know that the ratio of the velocity diagram is totally equal to ratio on a space diagram, and you will find the any point on a velocity diagram as well as on a space diagram. Okay,